My name's McNevin and I'm an Assistant Professor of Forensic Studies at the University of Canberra. I first got involved with forensic science 10 years ago as a postdoctoral fellow with the Australian Federal Police, and I've been at the University of Canberra since 2007. My area of expertise is forensic genetics, which is the use of DNA to aid in forensic investigations. DNA profiling has revolutionised forensic evidence since it was first introduced nearly 30 years ago, so much so that it's now referred to as the gold standard of forensic evidence. The use of DNA as forensic evidence is now routine in many countries throughout the world, including in Australia. In standard forensic practice, it's used as a means to identify an individual, and we can do this from trace quantities of biological materials left behind at crime scenes, including blood, hairs, and even fingerprints. We're constantly looking at any added value that we might be able to obtain from DNA. If there are no suspects, or very many of them, we have no one with whom to match a DNA profile. What other information can be obtained from DNA recovered from a crime scene? We're trying to predict what the DNA donor looks like so that a photo fit of a potential offender can be issued. Photo fits have been used routinely in the past, usually as a result of eyewitness accounts, but these are notoriously unreliable. We've developed a high-throughput DNA profiling assay that allows us to identify an individual as well as predict their ancestry, eye and hair colour, all in the one assay. This can now be done faster and cheaper than current methods used in forensic laboratories. Hence, we have a better DNA profiling technique with far more information available to forensic investigators for no extra cost. We're already able to predict a person's biogeographical ancestry, their eye colour, their hair colour, all from their DNA. What other traits can we add? This forms a central part of our research, with the ultimate aim, perhaps some time away, being the reconstruction of a full suite of biometric traits, including facial profile, fingerprints, and other aspects of what they look like, all from a trace quantity of DNA.